learned everything from Kaggle community, Kaggle competition, Kaggle computing resources. Hello everyone, my name is Yuta, and thank you, Mari, for taking time. We ended up second place in tweet sentiment extraction competition, and we fought in this competition almost 3 months, and it was tough time for all of us. But we could really enjoy that time. That was fantastic time for all of us. I remember before the private leaderboard opened. So we are fighting from Japan. We are staying in Japan. So the private leaderboard opens 9 a.m. It was in the morning. And I remember we are communicating in Slack. And in the 9 a.m., everyone, so we were around 5th out of the money position. After private leaderboard reveal, we chatted, oh my God, and what happened? And I really remember that time, and I would like to thank all of my teammates. So I joined Kaggle 2 years ago, and my first competition was home credit, and I entered some competition, image competition or text competition or table competition, and so on. And tweet sentiment extraction was my around 10th competition ever. And my background or academic background is not about machine learning or computer science. I was in optics or telecommunication department. I was studying optics when I was a graduated student, and I didn't write a code at that time. I was kind of wearing goggles and wear white coat and measure how laser works in using optics, for example. So after I graduated university, I entered a consulting company, and that was my second year of my consulting company. I met Kaggle and machine learning, and I learned everything from Kaggle community, Kaggle competition, Kaggle computing resources, and so on. So I really thank Kaggle.
My name is Hiromu Takashi, and my Kaggle username is Hiromu. I'm an undergraduate student majoring in informatics. For example, I'm learning bioinformatics and statistics and so on. I joined Kaggle 3 years ago, but I didn't know what to do at the time. Then I started studying machine learning hard. So my first competition was a Santa 2018 competition. But after joining that, I noticed it's too hard for a newbie. So I selected Quora as my next competition. I think that was a good decision because I like text data now. And I was fortunate enough to take third place in last year's Jigsaw competition. That gave me confidence and motivation to participate in this competition.
Hello, my name is Masahiro Yamamoto, and my Kaggle username is MY. I work as a machine learning engineer in Japanese company. My motivation of Kaggle is to improve my skills. The knowledge learned from competitions is useful for my job and vice versa. And my professional is computer science, especially natural language processing. So this competition is very interesting.
I'm going to introduce a brief summary of our entire pipeline. So this slide describes everything of our pipeline. We can divide our solutions, our pipelines, into 5 or 6 different parts. So our pipeline starts with pre-processing and base model and ensembles and relinking models, and finally we ensemble our model. And also all of our model output is post-processed. So I said 5 or 6 main parts we have in our pipeline. So each part we are going to explain from this slide. After this slide, we are going to explain each part a little more precisely, more detail. but I'm going to explain just the flow of our pipeline in this slide. So our pipeline starts with pre-processing. So of course, some of you may know the data is quite dirty. It had some kind of trick in the data. So we need to pre-process the data. And we feed that data into first base model. So we have different types of models, model 1 and model 2, and Roberta large and Roberta base. So Hiromu is going to explain what is the difference of model 1 and 2 in the next slide. So yeah, we have base model here. And we ensembled output here. And then we have another second layer model. We call it reranking model. And we relanked the potential output or candidates of the output from the base model. And then we rerank. And then finally, we ensemble the model output again here. And we use this ensembled output as final submission. So yeah, the days described here, for example, 7 days to 0 days, means we focused pre-processing in final last week. So we didn't spend a lot of time pre-processing. We mainly focused on base model. So we spent almost all of the time in base model. And the second, we spend ranking model 25 days here and post-processing, and we didn't spend much time in Ensemble and pre-processing. That is the kind of brief summary of our pipeline. So in the next slide, we are going to dig into base model first. So Hiromu is going to explain base model.
From this slide, we explain the base model. This part is the core of our solution because we kept improving it from the beginning to the end of this competition. First, let's talk about the model architecture. As you know, BART works really well for a lot of NLP competitions. However, in this competition, it performed much worse than Roberta. Our CV result was minus 0.01. That was a pretty terrible result. So we adopted Roberta as our base model. There are some differences between BART and Roberta, like training methods, training data, and so on. You can check the detailed explanation at the link number 2. Someone posted in tweet sentiment discussion board. And next, we'll explain 2 model types. One is only using the second from the last hidden layer. The other is using a trainable vector to define the weight for each hidden layer and multi-sample dropouts. This idea is come from first place solution of Google Quest competition. The left-hand diagram shows the model type only using the second from the last hidden layer. The second from the last hidden layer means the 11th layer in Roberta base. Because they have it has 12 layers. So we used it as output, which shape is bat size, token length, and 768. Here, the token length is length of tokenized text and padding. Then apply a linear transformation, which shape is from 768 to 2. Here, the 2 features represent start and end, respectively. And then apply argmax to each one of them and get the start and end token. Finally, we can get the phrase, which is between start and end token as base model's answer. The right-hand diagram shows the model type using a trainable vector and multi-sample dropouts. We used a trainable vector to decide the weight for each layer. This means we can find the best way to use all of the hidden layers information. Then apply softmax and weighted sum to get a single output, which shape is same as left hand, but size and token length and 768. And next, we adopted multi-sample dropout here. Multi-sample dropout works exactly as its name implies. Apply dropout not only once, but many times, and get multi samples. And this contributes to diversity. The remaining parts are the same as the left-hand one. We trained each type of Roberta base and large into different seeds. So our final base model contains 8 models. In the next 2 slides from here, we explain the training strategies we use. Our training strategies are mainly focused on how to get a stable and reliable CV score. We monitored CV score every 5 iterations with batch size of 32. So 160 records for a monitor. But it varied around 0.005. The 0.005 difference was a very big issue in this competition. One of the solutions to this issue was stochastic weight averaging, or SWA. Using this technique, we can maintain a running average of the weight obtained in the entire training process. Please take a look at the figure upper right side. This shows the training result of with SWA in orange and without SWA in purple through 2 epochs. With SWA result are applied SWA from the second epoch. You can see the orange line in the figure shows the really stable results. While the purple without SWA results fluctuate every 5 iterations, and you may pick one fluctuated peak. This makes a CV score unstable, and it is difficult to compare different experimental results. Finding early stopping point without SWA was really dangerous. The below figure from PyTorch blog shows SWA concept. Blue dots means model weights at each point, and averaging them is the key idea. SWA works really well. In most cases, a CV score varies less than 0.002 and constantly increased. In this slide, we'll explain other techniques to achieve a stable CV score. Firstly, a sentiment sampler. Using sentiment sampler, we equalize the sentiment imbalance within a training batch. The reason why we adopted this idea was the neutral record were easy to run. While Jackal score of positive and negative records are around 0.53, neutral one was over 0.97. So if the batch contains many neutral records, it looks like a good result. As you can see from the graph of the right, using the sentiment sampler not only stabilized the results, but also improved the score. Secondly, a different torch manual sheet. Changing torch manual sheet affects the initial weights and the order of records, etc. We tried at least 4 different sheets to decide whether an idea is good or not. And this technique can be used to choose the best seed for each hold. Thirdly, validate every 10 to 50 iterations and save model weights. In most cases, we check the validation score on the epoch end. However, we did it every 10 to 50 iterations to save the good weight. Considering the instability of training, this technique played an important role. And trust your CV. CV was also important in this competition. As you can see above, our models are little overfitting for CV, not publicly available. However, we could get some degree of correlation to the public readable, so we trusted it and finally got a great result. And finally, at the end of the base model part, I will explain another important technique, sequence bucketing. The idea is as follows. Each record within a batch had to be padded to the same ranks. However, we don't need to pad them by the max ranks of entire records. So we use sequence bucketing to pad by the max ranks of each batch instead of entire records. A simple example is shown in the figure on the right. In this case, where the batch size is 3 and the max length of entire records is 7. Using sequence bucketing requires the ranks from 7 to 5 in batch 1. This method is important for two reasons. One is speeding up training and inference time. The other is improving score because we can ensemble more models within time constraints. This method is also used in the re-ranking model part. We'll explain it next slide.
Okay, next, I would like to talk about re-ranking. Our base model can predict not only a top 1 selected text candidates, but also top-n candidates. So re-ranking means that we rescore these top-n candidates. We calculated the upper bound Jaccard score of top 5 candidates in the validation set, and that was 0.87 to 0.88. If we choose only the top 1, the score is only 0.71 to 0.72. Of course, this score, 0.71 to 0.72, is equal to the CV score of the base model. So we realized that there is a huge room for improving the score by re-ranking. In fact, in the field of question answering, similar to this task, the re-ranking approach is also developed. To re-rank candidates, we use two scores. The first one is based on start and end value after applying softmax from base model. The second one is a predicted Jaccard score using ranking model. The first score was explained by Hiromu, so I would like to explain the ranking model. The input of the ranking model are triple: sentiment, tweet, and candidate. The output of this model is a Jaccard score. In concrete, we calculated top 5 candidates in training and validation set and memorized the Jaccard score. For model, we used a simple Roberta-based model and MSE loss as a loss function. And this slide shows the improvement of re-ranking. The improvement of private reader board was 0.003 to 0.005. This improvement is not trivial. If we did not develop this model, we cannot win. However, we felt anxious before competition ends because the improvement of public reader board is little compared to that of CV score. Actually, the improvement of private reader board was same to that of CV score. So I feel trusting your local CV is very important. Next, I would like to explain post-processing. The annotation of provide data is little noisy. For example, the selected text of this text is back home now, gonna miss everyone is Ona. This is strange. The sentiment of this tweet is negative, so it is likely that the correct selected text is missed. We hypothesized that spaces cause this noise. In original text, there are 6 spaces between now and gonna. However, when someone annotates selected text, this space is removed like this, and the annotator select miss. This annotation was saved as start and end positions. When the organizer makes dataset, removed spaces are recovered, and the annotation is selected based on start and end positions. We think this procedure makes dataset noisy. We implemented post-processing based on the hypothesis. In concrete, we shift start and end positions of predicted candidates. Also, we pre-processed the provide data for cleaning based on this idea. The improvement of private reader board was 0.012. This improvement was very large. Most of the team in Goal Zone applied post-processing, so post-processing played an important role in this competition.
So as I explained in the pipeline, entire pipeline, we have 2 ensemble point after base model and after reranking model. So in this slide, I'm going to explain how we ensemble base model, the first layer model. So let's say input is that very funny. So we have tokens that period, very funny period. And we input these tokens into models. So model 1, 2, 3, 4, 5. And output becomes like this. So base model 1 says the start probability of that is 0.1 and period comma, this is actually comma probabilities 0.2 and so on. And we take weighted average of those probabilities. So for example, the start probability of vary for vary becomes 0.5, for example. And probabilities for end probabilities for each tokens can be calculated same as before. And for example, in this case, funny becomes 0.6 probabilities. So this is how ensembled base models in our pipeline. This is actually very simple and very ordinary way to ensemble models, but the second layer model ensemble is a little tricky. We use two input information. The first information is candidates. In this case, very funny or funny period. Those are the candidates. And the probabilities calculated in the base model. So very funny has probabilities of 0.55 because very has 0.5 and funny has 0.6. So we take an average of those two tokens, and 0.55 is the prediction of prediction from base model. So we input those two information into reranking models 1, 2, 3, 4, 5, and we can get the probabilities of probabilities to those candidates, which is predicted by reranking model. So let's say reranking model 1 says very funny has probabilities of 0.6, and reranking model 2 says 0.4 for very funny. And we just take a simple average of those probabilities, and the average of reranking model becomes like this, for example. Very funny has 0.5, and funny has 0.65, and funny period has 0.55. And we took an average of the ranking model output and base model prediction, and we finally use this red numbers as a final output. So in the base model, in a first layer, the very funny is the highest probability, has an highest probability 0.55. But after take an average of reranking model and base model, funny, just funny becomes the highest probability. So because of this reranking model, we could successfully rerank the candidates, the order of candidates. So this is how we ensembled in the second layer models. All right, so we explained all of our factors, key points in our pipelines. So Maggie, if you have any questions, we would like to answer.
That was a really clear and interesting presentation. I want to thank you again for all of your hard work and achieving second place in the tweet sentiment extraction competition. I really liked what you said about trusting your cross-validation. Have you been in other competitions where maybe you haven't done that and it's, cost you positions on the leaderboard?
So in my personal experience, in a malware competition, I didn't trust my CV and finally ended up from top 20 to around 50%. So I learned a lot from that shakeup, and trust CV is important. I experienced so much.
For a new Kaggler, what advice would you give them?
My teammates have different opinions, so if you have, please say something. But from my point of view, be open. Don't hesitate to discuss in a discussion thread. If you have some questions about how to write a code or how to understand this, for example, eval metrics, for example, you can just ask other competitors, and you can find something new. Or in order to, if you prepare your question, your way of thinking is becoming more, your idea makes clear.
Yeah.
So that process is still meaningful. And
Yeah.
if you get clear answer to your question, that is also meaningful. And you can find friend, for example. I haven't met my teammates in offline.
Yes.
You can find friends.
My other question is, how did you three come together?
Oh, we just met in a leaderboard and discussion. We had a discussion in my question thread, and Hiromu answered my question, and
Yes.
we changed our ideas in a discussion. And then how about merge a team? So be more open is kind of good hint or cue to newcomers.
I totally agree Mr. Walker's opinion. Because last year's jigsaw competition, I was a newbie for natural language processing. So I asked some questions on discussion board. Some grandmasters and masters answered my questions, so I can get some insight and motivation.